All right, in learning target 6, we're still we're trying identities like we did in learning target 4. But they're all going to be based off of the sum and difference identities. So these are easier to start because there's a starting point, and they aren't as complicated. So from now on, if you see anything where it says sine of a sum or cosine of a sum or tangent of a sum, you should immediately think of, oh yeah, there's an identity for that. All right, because if not, you're going to be like trying to add 90 and a together, and that's not going to work. All right, so you have to think about the identities. Again, you don't have to memorize these. They're on this red formula sheet for pre-calculus. Okay? All right, so I'm going to write down what the identity says for sine. It says sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. All right, that's what the identity says for the sum. 90 is your alpha, and then a is your beta, if you will. We're going to fill it in. So I need to expand that side out. Obviously, I can't expand cosine. Like cosine is cosine. What are you going to do with that? Nothing. So you need to expand out the left-hand side that's the identity, and hopefully things work out in our favor. So we have sine of 90 degrees times cosine of a plus cosine of 90 degrees times the sine of a. Any questions about where any of that came from? Or why I did that? I filled in this whole thing. I just filled it in. Sine of 90 and cosine 90 are in the unit circle. They're actual values. So the sine of 90 is 1, and the cosine of 90 degrees is 0. So 1 times cosine A is cosine A. Yeah. And 0 times sine A is 0. So we have cosine A is all that's left over, and that's what it's supposed to equal. So cosine A equals cosine A. All right, so generally these work out better. You have a starting point, so you know exactly what you're supposed to do. That was the problem in learning target 4. You guys were like, I don't know what I'm supposed to do. These have a starting point. Okay. Question of the first example. Can I erase it? No. All right. For the next example, don't write down, I'm going to write down for a second. All right, I'm going to start this how I started it and how you guys would start it, and then we're going to get stuck, and so we'll have to reevaluate some things. It's fine. It's still going to work out. So we have tangent of theta plus pi over 2. So I said you should use identities, so why wouldn't we use tangent, all right? So if I do that, and you fill in the identity, it says tangent theta plus tangent of pi over 2 over 1 minus tangent of theta times tangent of pi over 2. Here's the problem. Tangent of pi over 2, y over x, gives you 1 over 0. And what's 1 over 0? Undefined. Undefined. So you suddenly have undefined in the identity. You can't do anything with undefined. That's the whole point of undefined. Like, we don't know what that means. So you can't do like something plus undefined and get something else. That's not going to work for you. So this approach wouldn't work in this scenario. All right, we need to alter what we have a little bit. Okay, so that is where I started. It's where you would start, and it doesn't work out. It's okay. What else do you know about tangent, though? How can I rewrite tangent? Sine over cosine. So I can rewrite this as sine of theta plus pi over 2 over cosine of theta plus pi over 2. Again, both of those have an associated identity. And then hopefully that will work out and we won't get these undefined bits. You can even see on my work in my binder, you can see where I started with the tangent one and it didn't work, and so I stopped and moved on. Okay? All right. So again, you have to use your identities from the formula sheet or from your note sheet. All right, there's an identity. I'm just going to fill it in. I'm not going to take the time to write it all out. I'm just filling it in. Okay? So I have sine of theta times the cosine of pi over 2. You can. And cosine of theta sine of pi over 2. So I'm just filling in the identity. I'm not going to take the time to write the identity down again. And then for cosine, we have cosine of theta cosine pi over 2 minus sine theta sine pi over 2. Okay. Now, sine and pi over 2 and cosine of pi over 2 is the same thing as sine of 90 and cosine of 90. So again, those are numbers. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. So, what? I just made it 0. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. I was just writing over it, so I have to write it all the way back out again. 1. So you can rewrite it all out if you wanted to. I was trying to save time. Okay. All right, so sine of theta times 0 is 0. So like that's just 0. Cosine of theta times 0 is just 0. So that part's just 0. So what I'm left with is cosine times 1. So I've got cosine theta. And then I have, don't forget this negative down here, I have negative sine theta times 1, so I have negative sine theta. Which is what we're trying to get negative cotangent. So cosine over sine is cotangent. We have a negative, so we get negative cotangent equals negative cotangent. Questions about any of that? Questions before I move on to the last one? It's good. All right. On the last one. Now this time you don't have, we still have a difference identity, but this time we don't have any numbers in it. So we're not going to have to use the unit circle so much. What we need to do though, is we need to rewrite sine of x minus y as the identity, so at least we know what we're trying to get to. Okay? So I'm just going to rewrite what the identity says. I'm trying to get to sine x cosine y minus cosine x sine y. That is what the identity says. So that is what I'm trying to achieve. So in this one, obviously we have to rewrite some things. We're going to have to rewrite the right-hand side to make it look like this identity. The identity is all in terms of sine and cosine. So then what should I be doing on the right-hand side?
Sine and cosine.
Making everything sine and cosine. Now, you have to be very careful. Just like yesterday I said you had to make sure you had the variables included. You have to make sure the variables are included today, because if not, you're going to cancel things out that don't actually cancel out. So make sure you include the variables. So cotangent is what?
Cotangent is cosine over sine.
All right, so cosine x over sine x. And then tangent is what over what?
Sine over cosine.
Right, but this is y. So I just wrote cosine. I wrote sine twice instead of cosine. There we go. Okay. So the sines and the cosines don't cancel out because you have different variables. That's why it's very important you write the variable. In the denominator, how can I rewrite cosecant? sine.
Sine.
And then secant I can rewrite as,
1 over cosine.
all right. I'm just going to rewrite this really quickly where everything is multiplied together instead of having these parentheses and things. So I have 1 minus cosine x sine y over sine x cosine y over 1 over sine x cosine y. Now, I know sometimes you guys think that you're making them more complicated and you're not sure if you're on the right track or not. And so here's what I would be looking at. I know I need to have a minus cosine x sine y. So I kind of have that in the works. It's sort of there. I also need a sine x cosine y. You can see that they're in the denominators, and maybe those will cancel out or something, or so everything will work out with that. And I also have to have sine x cosine y in my identity, so all the pieces are there. It's not finished yet, but we're on the right track because all the pieces are there. So you could, there's two ways to do this. You could get a common denominator in the numerator, and it'll work out that way. I'm just going to make it shorter than that. Okay? You can do that. So if you did that, it wouldn't be wrong. In my approach, I'm dividing by a fraction, and so how do I undo dividing by a fraction? You multiply by the reciprocal. So here's the numerator. And I'm going to multiply by the reciprocal. Now, you have to distribute. So sine x times cosine y times 1 is just sine x cosine y. Mm-hmm. I multiply by the reciprocal. So I was dividing by a fraction, and now I'm just distributing. Good plan. And then I'm going to multiply sine x cosine y times this fraction. And by doing that, the numerator and the denominator cancel out. So I just have minus cosine x sine y left over, which is what I'm supposed to get way up here. Sine x cosine y minus cosine x sine y. All I do is multiply by the reciprocal and distribute. What we're supposed to get to. Yeah. Question?